so today, as I said before, we'll be looking at polymers. So, a polymer is basically a macromolecule that is formed by linking together 50 or more monomers, usually in chain. Macromolecule that is formed by linking together 50 or more. That's the definition seen in this book. 50 or more. Right? So monomers, polymer, macromolecule. So macromolecule, they're a very, very large molecule. Alright? And polymers is just a, when we say linking here, actually it's actually a chemical reaction that will take place. So when we say linking, it's a reaction that is taking place. So the monomers, that are small molecules, will react with each other to form a long chain of compounds with 50 or more of the monomers, which are the small units, to form what we call polymers, right? And polymers are stuff that we use in everyday life, alright? And for example, we have the plastics. The synthetic polymers are called plastics that we see every day. So you can see, like, we have the PVC pipe which they use in plumbing, and even the plastic around the electric cards that you would use, Mr. Harding, in your work is also a polymer as well. Alright? So we have both natural and synthetic polymers, which we'll get into later. Alright? But just to note that in terms of the formation of polymers, right, we have two types of general types of reactions that can take place to form them. Right? We have one, addition. Right? And two, we have condensation, polymerization. Alright? So that's the basic introduction there. So we're going to look into both addition and condensation, polymerization. Alright? And both types can be synthetic or they can be naturally occurring. Alright? Except that I'm seeing in the book here where in terms of the addition, polymerization, those are normally formed from unsaturated unsaturated organic compounds, right? So if you remember when we were doing alkenes and alkanes, we normally say that the alkenes will undergo addition reaction because they're unsaturated, so we can always add a small molecule across that double bond for it to become saturated. That was one of the reactions of alkenes, right? The addition reactions. And several different additional reactions that could have taken place. Alright, such as when we use like the addition of hydrogen, addition of water, addition of hydrogen halide, etc. If you can recall from last week's class, right? So just to know that additional polymerization is when we use, for example, molecules like ethene, right? It will form polyethene, and normally this is what they use to make like plastic bulbs, right? And it is just basically reacting lots of ethene molecules together. So basically just join together in a chain to form just one long polymer with all single bonds. Alright? So addition polymers are polymers that normally all the monomers will come together to form the polymer, and it's a addition reaction. So no byproduct is produced. So the small molecules will just join together to form one long polymer, right? And all the units are normally identical in a addition polymerization because the same compound itself is just going to react to form long chain compounds, right? So as I said before, whenever the monomers react with more than 50 or more of them react, it will form long chains called polymer. Right? Right? So an example is polyethylene. Polyethylene, right? So the monomer for this is basically ethene. When the 50 or more ethene molecules form addition reaction, so remember that what's happening when the monomers react is that another ethene molecule will be over here. Right? So what happens is that this double bond, so remember that 2 electrons will make a double bond, right? And this double bond there, they will actually break, and this electron will go and react with this electron, right? So what we actually have here, C, so this carbon, so let me just label this. So for example, this is 1, 2, 3, 4. Alright, and let me draw a third molecule. Because why I'm doing this is that in the exam they will normally ask you to use about 3 monomers to show the structure of a polymer in the exam setting. So let's just use 3 molecules from here. Alright, so this is a 5, 6 carbon. So it's 3 different ethene molecules, right? So this is still carbon number 1, carbon number 2. This third molecule here. Right, so remember that there's still 1 electron in this carbon which can join with another ethene molecule to extend the chain. Right? So this is another carbon. Right? So this is 3, 4, and then this third molecule now, C, which would also have a free electron there which can form an additional extension of the chain. Alright? So this would be an example this would now be an example of the polymer, and then we would represent a structure with 3 different monomers of the polymer like this, right? So this structure that we are seeing here, as you can see, it turns out to be a long chain alkane for polyethylene, right? Because the different monomers, which are all ethene molecules, will all join together to form a long chain hydrocarbon with all single bonds. And this can actually, that is why we represent it, like we'll put an N here, where N can be like very large numbers. So this N would have to at least be like about 50 different of these units for it to become a polymer. Clear? And remember that for polyethylene, they use it plastic bags, plastic bottles, wash up bowls, buckets, etc. is polyethylene material that they use. So scandal bag, polyethylene. Alright? You want to use that term.
Polyethylene, I need that like for pipe. Conduits.
No, this is for plastics.
Okay.
They will use polyethylene plastics, right? Because you have to know the different types of polymers and what they are used for. They will ask that in the exam, alright?
This is used for what?
Plastic bags.
Standard
bucket, yes. So plastic bags, buckets, packaging for food and wrap, right? And wash bowl, etc. Right? So next we have polypropylene, very similar to polyethylene, but as we know for polypropylene, right? So remember that this would be so instead of this would be a CH3 here, right? So instead of a hydrogen, it's propene, so 1, 2, 3 carbon atoms, right? So it's plus C plus, I remember in the exam they always wanted to show at least about 3 units for the most part. So let's just practice the exam style from now. So remember that the monomer in this case is, so the monomer is propene.
There's three atoms.
3 carbon atoms.
3 carbon atoms.
Propene, okay? Good. And then the polymer that is formed so this will take care of this molecule, right? 2 carbon atoms is hard, then you're going to go to this carbon atom, now it's going to have a CH3 and a hydrogen. This one will be, this bond will also be broken to form H, right? Goes here, this one will go to that one, right? So 1, 2, 3, 4 so far, right? Then we have this carbon, so this now 1 electron from this carbon atom is going to bond with 1 electron from this carbon atom from this double bond, right? Right? So, if you're following, what should be here and here? So if you're following the structures, what will we put here?
H, hydrogen.
Parts, what should we put here? Following my trend that I'm doing here.
CH3.
Good, CH3. What should we put here?
H,
Yes?
H, and H.
Alright, so this is polypropylene, and right? So polypropylene used to make ropes, carpets, plastic toys, plastic food container, and furniture. Right, Mr. Harding?
Yeah.
So unlike polyethylene, which used to make scandal bag and other stuff like that, it probably used to make that. This is a little stronger, so they use like make plastic chair, ropes, etc. and plastic toys for the kids. Alright? And again, all addition polymerization are all synthetic, so they are all man-made. Alright, so both polyethylene and polyethylene and polypropylene, they don't exist naturally in nature. They are man-made, so actually they are synthesized in labs and factories. Alright? That is why, if you notice, and you should see the plastic bottles and the plastic bags in the environment, they are not biodegradable, so they will stay there as long as the earth exists. Alright? If we don't recycle them. Alright? Alright. So both polyethylene and polypropylene are hydrocarbon. But also remember from the earlier reactions of alkanes and alkenes, we can actually add a halogen, such as chlorine, bromine, iodine to the hydrocarbon, right? So the third addition polymer that we're looking at is polychloroethene. Okay? And this is PV. Yeah, but PVC is from the alternate. But this is PVC, but it's not coming from this name. This is the IUPAC name, but the original name for it was polyvinyl chloride. So I still wanted to remember PVC because it's a very popular question in the exam. PVC, alright? So polyvinyl chloride. So PVC is very popular to say PVC. So now we are seeing where the word is coming from, right? And the monomer for PVC is actually chloroethene, right? Chloro monomer. Chloro. What's the structure of chloroethene, Mr. Harvey? Chloroethene. I remember that they have to know that in the exam, you have to know how to draw names, structures from name, and names from, and you have to know how to name the structures. So that's two things you have to know for organic chemistry in CSEC, right? Cl is here, hydrogen, hydrogen, hydrogen. So it's a chlorine, ethene, 2 carbon atom with a double bond. Right, that is why its name is chloroethene. So whenever we have like 50 or more of these molecules joined together, it will call the polymer, which is known as PVC, which is polychloroethene. It's a polymer, right? So let's keep them consistent, right?
And the ethene is always 2 carbon.
Yes, because remember that eth indicates 2, you know.
Ethene, so just
yes.
the
And meth is 1, probe is 3.
So if you ever never have the chloride, then it wouldn't be just ethene alone.
Good. Alright. So what we produce here, well, this is how you draw the actual polymer, represent the polymer. So it's a CCl. So that's the first one, right?
Okay.
So we're going to break this bond. So this carbon is going to bond with this carbon.
Okay.
So I don't have to number them, alright? You will follow. Cl is here, hydrogen. So that's 2 monomer joined together thus far. So we're going to add the third monomer, which would make 6 carbon atoms that I'm going to represent in total. Okay?
So they always add up to 6?
No. In exam, they normally want ask you to
just
represent
because they use 3.
Yes. That because they want to at least show that you know that it's 3 of them. But you have to know the definition in reality is that a polymer itself is when 50 or more of the monomers join together. Because remember that one chloroethene molecule would be microscopic, invisible. So it would be, even if it's one molecule, you would be unable to see it. And you could imagine that if we can see the PVC pipe, it's actually millions of molecules joined together, billions of molecules. But in definition, for a polymer, it is when we have 50 or more of the monomers joined together to form a straight chain. Alright? And PVC, this is one that you should remember, is used for water pipes, gutter windows, door frame, insulation of electrical wires and cables. Alright, so this is your polymer, Mr. Hardy. This is the one you use every day, basically in your work. Clear? So this